All right, guys, welcome back again to the next session. And as we are continuing with model-based development, and we have presenter from Gamma Technologies, Joe Wimmer, senior engineer from Gamma Technologies. Uh, Before he jumps into his topic, I would like to just give a brief introduction about Joe. Joe Wimmer has been with Gamma Technologies, a leader in system-level simulation software for over 7 years. His work as an application engineer includes supporting clients to build system-level models in GT Suite across many applications, including full vehicle level models of conventional and electrified vehicles, battery system models, and electric powertrain system models. So today, Joe is going to show us how JMAG and GT Suite integrate together, and also a little bit give an overview of what GT Suite is all about. With that, I will go ahead and welcome Joe onto the screen. Here you go, Joe.
All right. Thank you, Ved. I'll go ahead and share my screen here. Okay, I guess just to confirm, you can see my screen, Ved?
Yes.
Okay, great. Thank you. So I know we're running a little late. I'll try not to rush too much, but also try to be cognizant of the fact that we started late. So I'll try to kind of speed things along a little bit. So again, my name is Joe Wimmer, and I work at a company called Gamma Technologies, and we are like JSOL, we create a software tool. Our software tool is called GT Suite. And so what my presentation is focused on is talking about some of the integrations between GT Suite and JMAG. And we'll be highlighting the newest integration between JMAG Express Online and GT Suite, as well as others, including JMAG RT. So since this is a JMAG conference, a JMAG users conference, I imagine that many of the attendees have either never heard of GT Suite or are not entirely sure what it is. So before I really dive into the main brunt of the presentation, I just wanted to spend a few minutes talking about what GT Suite actually is. So first and foremost, GT Suite is really a multi-physics modeling platform. And so I know we use the term multi-physics a lot, so I want to kind of dive into a few examples there. Of course, we have electrical domain modeling capabilities, including being able to model things like electric machines, inverters, batteries, fuel cells, all the way down to just simplified electrical components. Additionally, one of our strengths is definitely going to be in the thermal modeling capabilities. So we have a number of thermal modeling options, including thermal networks, where you might picture just one-dimensional thermal masses and conduction, convection connections. But we also do enable finite element analysis, as well as a mixture between these two. So you can have some components using finite element and other components using thermal networks in a very straightforward manner. We also have fluid flow, and this is really going to be the world-leading one-dimensional fluid library. And so one-dimensional fluid flow is really, if you have a pipe, you would just assume that that entire cross-section of the pipe is homogeneous. And so with that, we're able to model any type of gas, liquid, even two-phase, as well as air-fuel mixtures, anything and any really shape of these types of pipes. We also have mechanical modeling capabilities. So again, this presentation is kind of focused around vehicle modeling and hybrid vehicle modeling specifically. And so applicable there is going to be things like driveline mechanics as well as vehicle mechanics. And at a high level, this is really the GT's power, or the power that is GT Suite. It's really being able to take all of these complex and multiple types of physics into a single virtual integrated system. And so we've spent a lot of years developing our tool to make the connections between these domains seamless. We also have things like optimization, DOE capabilities, as well as even being able to run real time on HIL and MIL and SIL systems. But again, not only is GT Suite multi-physics, but really kind of the differentiating factor of GT is here we just have a very simplified spectrum talking about all the different simulation tools that might be out there, where things might take either seconds to simulate. Maybe you have internal Excel scripts that do simple calculations. Maybe you have Simulink, all the way to the right where it might be 3D finite element analysis, things like the deep electromagnetics within JMAG Designer, maybe even 3D CFD tools for flow. And that could take, depending on what we're simulating, it could take hours or days or a large multiplier on real-time capability. Now, GT is really kind of set to be in the middle of this, kind of between the sort of simplified Simulink models and the very detailed three-dimensional CAE models, where this is kind of our power to be able to bring in some of that model fidelity, not necessarily all of it, into system level simulation. So we often use the acronym PBSE. So you can often hear MBSE, model-based systems engineering, but we usually like to talk about physics-based systems engineering. So all these templates are actually physics-based, and so there aren't any causality issues when in modeling in GT. And so we have a lot of customized solvers, and some examples of that are going to be things like heat exchangers. We can bring in our 1D and even make it quasi 3D flow domain in order to model the flow around a heat exchanger and keep it also very fast running models. This also includes cabin modeling. We have a special coupling capability with a tool called Titherm in order to be able to accurately capture cabin temperatures as well as human comfort, since we all know whenever we're looking into hybrid electric as well as battery electric vehicles, there's a huge trade-off between customer or driver comfort and passenger comfort, as well as range. On top of that, as I said, we also have one-dimensional flow, and this is going to be able to put together all of those different pipes that are going around in a vehicle, whether it's connecting the radiator to the power electronics or the motor. All these different things can be set up. It could be the two-phase refrigerant loop. All this can be modeled and set up in GT. When we're talking about the powertrain, when it comes to batteries, we also have GT Autoline, which is an electrochemical modeling tool for lithium-ion cells. That's very powerful. For motors, we can bring in more detailed inverters, as well as, of course, JMAG RT, which I'll be talking about later. And then finally, for things like vehicles, we can have very simple vehicles that have like a simple bicycle model, and we can also go all the way to three-dimensional mechanics in order to look at suspension and how it plays a role in the vehicle. Okay, so with all that, I kind of wanted to again spend a few minutes there, and now just kind of pulling back and talking back about the main presentation, which is talking about the different ways that JMAG and GT communicate between each other in order for more comprehensive model development and component development that goes all the way from system level to, again, detailed component level between the two tools. So this, for those of you that have seen this 100 times before, I apologize, but this is a standard V cycle. which represents the overall vehicle development cycle in the electrification era, where basically we would start up on the top left, where the top is basically the full system. And then as you get deeper into the V cycle, we're talking more detailed components. So kind of starting with full vehicle requirement definition and simulation into the actual things like motors and battery design, and then detailed design and analysis, and then kind of putting them all back together for later integration and validation. So again, since this is a JMAG conference, kind of focusing in on motors here. And first wanted to talk about the vehicle level requirements and some of the things that GT has to offer here, and of course, what we do with JMAG, and in this case, JMAG Express Online, in order to accomplish some things here. So at this stage, basically, this is what I would consider the concept level design for vehicle levels. So here, the inputs at this stage might be things like vehicle requirements, whether it's range, how far, if I'm making a BEV, what's my desired range, my target range of this vehicle. It could also be cost. If you're talking about the range, you can have a high range or a low range, and that might affect the underlying price band of what you're shooting for. And then, of course, performance. BEVs and HEVs still have to compete with conventional vehicles. So making sure that those vehicles are able to go up the same amount of grade, have good acceleration from rest, have good passing requirements, and the like. And then the output of this stage is generally going to be the architectures that we want to move forward with, as well as performance requirements for some of these subsystems, like the batteries, the motors, the cooling system. We might be able to define some requirements for those systems. The big challenge here is really, how do I go from these vehicle requirements to these performance requirements of the subsystems or even the architectures? And so with GT, we're able to put together any type of electrified vehicle, including things like pure electric vehicles, mild hybrids, which might look something like this in the GT software. Series hybrids, where you're basically having a generator connected to an engine, and then an electric vehicle as the traction motor. P2 parallel hybrids are kind of a mix of the latter two. We could also have a power split hybrid, which is similar to the Chevy Volt, as well as the Toyota Prius. Or even some of the later models of vehicles are looking to have really this through the road technology, where it might be a P0 mild hybrid on the front axle, and then an electric drive on the rear axle, where you can get this sort of all-wheel drive systems. And then even, as far as outside of BEV, even fuel cell electric vehicles, where we can bring in PEM fuel cell models alongside, again, motors, including map-based or JMAG machines. Now, typically, most people who are at this stage of this system level simulation are going to be using map-based motors. And so what these map-based motors will have is generally an efficiency map or a power loss map, as well as just a max torque versus speed. And these efficiencies of power losses are generally functions of speed and torque. And this is pretty powerful in and of itself, because it effectively captures emissions and fuel consumptions if you have a hybrid vehicle, as well as range if you have a BEV, the amount of heat that's coming off, so you know how much how heavy of a load the thermal system will have, as well as how the load on the battery will give good results for that. But the big question mark here is, where do these maps come from? Especially if you're early in the development cycle, it's not always easy for these vehicle level engineers to have good data for these motors. So answering that, where do these maps come from? Kind of talking in about concept level design for these motors, and I'll kind of wrap it back up to that last section as well. So again, since we're at this JMAG conference, one thing to focus on is motors. And so generally what we'll see at this motor design stage is going to be motor requirements in the form of maybe torque, max speed, power, actual dimensions. We only have so much room in the vehicle, as well as cost. And then we might also even have some load profiles that could be power versus time or torque versus time. And the outputs here will generally be the motor design. So this could be whether we want to have a surface mounted permanent magnet, an internal magnet or internal mounted permanent magnet machine, or an induction motor. How many poles, how many slots, what's the actual design or the orientation of the magnets, all these questions. Again, the big question mark, how do we get from these requirements into this motor design? And here, as many of you probably know, a great answer to this question is actually JMAG Express Online. So with JMAG Express Online, you're able to directly enter some of these motor requirements and use that to come up with motor design. And then once you've come up with motor designs, you can actually experiment on them and make some small tweaks and changes upon what was automatically generated. And then from there, automatically have motor performance in the form of efficiency maps. And so this was a big new feature for JMAG Express Online, and I want to personally thank JSOL for developing this, because it's been very helpful for us. And that's actually going to be the ability for JMAG Express Online to automatically output maps or efficiency maps or power loss maps, where these might be, once again, efficiency versus speed and torque. And so there's a new workflow within JMAG Express Online in order to actually calculate and export these automatically. So again, kind of wanted to bring this back to this level and kind of bring this idea back is, remember at the vehicle level, I asked the question of where do these maps actually come from? A lot of the guys up there are vehicle engineers, not necessarily motor engineers, like I'm sure many of you are. And so what we see a lot in the market is actually iteration between these two stages. And this iteration kind of often looks like this, where we have, again, vehicle engineers who are looking at vehicle simulation, wondering what the battery loads are, thermal loads, fuel consumption, emissions, maybe it's electric vehicle range, what's the torque or power profile on the motor? What does that generally look like from these different drive cycles or other things? And then on the other side, we have these, again, motor design experts, where they're, again, designing the motor, and answering all those questions about how should the motor be designed from earlier. And what we see is generally these teams are kind of split. So again, we're iterating between these two teams, where the vehicle engineers might be sending motor requirements, maybe the torque versus time or power versus time load profiles. Motor design experts kind of iterate on their design and have motor maps ready for the vehicle engineers. And then this iteration might just continue for a few cycles. So to address this challenge, what we've actually done, and when I say we, I mean Gamma Technologies, what we've been able to do is partner and collaborate with JSOL in order to actually make JMAG Express Online accessible from within GT Suite. And so what this actually looks like, in order to kind of simplify a few things and the overall workflow, so I'm not jumping between applications, we recorded this video to demonstrate what this actually looks like. So this initial view is actually GT Suite. This is a battery electric vehicle within GT. And so we've made this new ability to actually access the JMAG Express Online UI from directly within GT. And then from here, you can use JMAG Express Online to build up all these different shapes and types of motors, including many others that aren't actually pictured here. And so at this stage, you can easily enter things like the rated power, the maximum torque, some of these requirements, and JMAG Express Online will automatically generate sort of a proposed design for that. And then this new ability to generate an efficiency map, it has been built in. And it's pretty straightforward to do. You can just set up the maximum voltage and current, and then we're able to analyze the results in this window here. And then finally, what we can do is actually display some of the results and actually output this in the form of a CSV file that will be later automatically importing into GT in order to basically have a map-based motor set and ready for this vehicle model to use. And this vehicle model can run drive cycle or multiple drive cycles. And then when this is running, basically what we would have is the drive cycle profile. I think this is going to be an NEDC drive cycle to start, where we would, or an FTP 75 drive cycle, where we're basically following a speed trace versus time and calculating the torque required from the motor as well as the speed required from the motor. So with this type of analysis, we're able to look at residency plots on the actual motor. So we can see, how frequently we're operating in these different portions of the motor in order to determine, okay, can we size this down? Do we need to size it up? Do we need to increase the number of slots or poles and different things like that? So with that development and with this partnership between GT and JMAG, we're really hoping to bring down some of these walls between these different teams and actually bring these teams closer together for faster and much more efficient iteration. So again, kind of we're trying to take these two stages and go from iterating in order to actually look at developing these together. So developing the vehicle level design as well as the motor level design and kind of working together a bit more collaboratively between these teams. So that was the main brunt of the presentation, but I also wanted to share a couple of other workflows that are available between GT and JMAG, and I think we're doing okay on time. I guess this is about the end time, but we started a little late. I'll try to go through these a little quicker. One of the main ones is, of course, going to be the ability to import JMAG RT models into GT Suite. And this has a number of applications, including being able to analyze the motor controls as well as noise, vibration, and harshness. So the motor controls and NVH in a system level simulation. So you can see how these things affect the entire system, not just the motor. JMAG Designer also has the ability to export heat transfer rates as well as forces in the form of CSV and Nastran files that in GT we can actually import into our finite element capability as well. And so what this might look like is the ability to actually analyze some of these different cooling strategies within the stator that could be modeled within GT. coupling that with predictive losses in JMAG Designer. And of course, being able to put that together within GT, and then being able to run models and actually analyze the temperature distribution between the stator, maybe the coils, and the overall entire motor. So with this, what we're hoping to do is, again, kind of trying to bring these different teams together a bit more between motor design experts and other teams, including controls engineers, whether these are motor controls engineers or just thermal controls engineers or system level controls. Noise, vibration, and harshness teams, as well as thermal engineers as well. So all these different teams trying to kind of be able to get them closer to the experts that you are with your expertise in motors and motor design. So with that, I want to say thank you. So thank you for listening, and especially thank you to JMAG for developing some of those features, and thank you to PowerSys for inviting me to present at this virtual conference. So again, thank you, and I appreciate the opportunity.
Perfect. Thank you very much, Joe. Thanks for that wonderful presentation and going over the entire suite of what Gamma Technologies has to offer and how JMAG Express and RT can integrate with GT. That is really good. We do have a couple of questions before we quickly switch on to the next session. One of the questions is it possible to vary JMAG motor parameters from within GT suite and automatically update efficiency map so we can run motor design optimizations within GT suite?
Yes. So unfortunately, we don't have the ability to do that just yet. Within GT, we actually just have a sort of a browser built in. We have been kind of in contact with JSOL to see if we can develop an option for us to be able to automatically iterate on that, but that's something that we definitely see as being very powerful, and hope to have soon. But yeah, right now what we're doing is we're pretty much just accessing JMAG Express Online in its current form. Instead of, we didn't necessarily rewrite JMAG Express Online for GT or anything like that.
Perfect. Thank you, Joe, for answering that.
No problem.
I'll take one more question. Can we save geometry data associating with the driving cycle simulation result?
Can you save geometry? What was the question?
Can we save geometry data associated with driving cycle simulation result? I think, let me...
Yeah, I guess the geometry that's...
The express data, maybe?
Yeah, the geometry that's in the JMD file or the JMAG designer file, which is still used in JMAG Express Online, would be saved. And then that can be, compared or saved with those residency plots or the maybe the BEV range that was calculated within GT associated with those designs. So yeah, absolutely.
Perfect. All right. Thank you very much, Joe, for that presentation. And we are a little bit over time. And
I know. Yeah. Sorry about that.
No, that's a very good insight and very good presentation. So we will switch to our last session for the day. And thank you again. We'll see you.
Yeah. If anybody needs to reach me, I'm on LinkedIn and everything. So thank you, everybody, for your attention, and have a good rest of the conference.
Thank you. Bye.